VICTOG.com.
Now we are starting a new chapter, Introduction to Trigonometry. Introduction to Trigonometry. Okay, Introduction to Trigonometry. See, Trigonometry is an interesting chapter, but one condition is that we must know thoroughly the basic ideas of trigonometry. If you are studying the basic thoroughly, it will be very interesting to do the problems on trigonometry. First of all, we are taking right triangles in trigonometry. We are considering right triangles and saying something about right triangles. See, here is a right triangle. Here is a right triangle. Here it is 90 degree. Triangle ABC, which is a right angle at B. The side which is opposite to the right angle is called hypotenuse. Here AC is the hypotenuse. Hypotenuse of the right triangle ABC. And the side opposite to the angle which we are considering is the opposite side. That means if we are considering the angle A, the side opposite to the angle A, that is BC, is called the opposite side. This is opposite side of the angle A, opposite side. And the side adjoined or adjacent to the considered angle A is called the adjacent side. First of all, we are considering a right triangle ABC, which is right angled at B. Now, the side opposite to the right angle is called the hypotenuse of the triangle, and the side opposite to the angle which we are considering is called the opposite side, and the third side which is adjoined or adjacent to the considered angle is called the adjacent side. Okay, we are taking a right triangle and a hypotenuse, opposite side, adjacent side. These three are obviously known. Now, if we divide the length of the opposite side by the length of the hypotenuse, we will get a ratio. That may be a fraction, a whole number, a decimal number, or anything. We are getting a ratio by dividing the length of the opposite side by the length of the hypotenuse. That ratio is called sine of this angle. If we are considering the measure of this angle as theta, if the measure of angle A is equal to theta, then we are dividing the opposite side, the length of the opposite side by the length of the hypotenuse. We are getting a ratio. That ratio is called sine of the angle theta, means sine theta. Sine theta. When we are hearing the word sine, we have to remember it is opposite side by hypotenuse. Sine theta is equal to opposite side by hypotenuse. The ratio obtained by dividing the opposite side by hypotenuse is called the sine of the angle theta. Which angle we are considering? The sine of that angle, that is sine theta, is equal to opposite side by hypotenuse. If we divide the length of the adjacent side by hypotenuse, then also we are getting another ratio. That ratio is called cosine of the angle theta. Cosine, the full name is cosine, and for our convenience, we will short the name as cos theta. Cos theta is equal to adjacent side by hypotenuse. Adjacent side by hypotenuse. Adjacent side by hypotenuse. So, remember, when we are hearing the word cosine or cos, it is the ratio obtained by dividing the adjacent side by hypotenuse. Adjacent side by hypotenuse is equal to cos. Now, if we divide the length of the opposite side by adjacent side, we are getting another ratio which is called tangent of the angle. For our convenience, we will short the name as tan theta. Tangent reduces to tan theta, tan of the angle theta. Tan theta is equal to opposite side by adjacent side. Opposite side by adjacent side. adjacent side. Now, the three ratios are very, very important, and this is the three basic stones of trigonometry: sin theta, cos theta, and tan theta. These are the three basic stones. There are three vertices for a triangle. Similarly, these are the three basic stones of trigonometry: sin theta, cos theta, and tan theta. If we are thoroughly knowing these three, then the remainings are very easy to understand, because the next three ratios are the reciprocals of these three ratios. That means the ratio which is the reciprocal of sine, that means we are dividing the length of the hypotenuse by the opposite side. We are dividing the length of the hypotenuse by the length of the opposite side. We will get the reciprocal ratio. The reciprocal ratio of sine is cosec theta. Therefore, cosec theta is equal to hypotenuse by opposite. The full name is cosecant theta, and we are shortly write it as cosec theta. Cosec theta means hypotenuse. Hypotenuse divided by opposite side. Hypotenuse divided by opposite side is cosec theta. Similarly, if we are dividing the length of hypotenuse by the length of adjacent side, we will get the reciprocal ratio of cos theta. The name of the reciprocal ratio of cos theta is secant theta. The full name is secant theta. We can reduce it as sec theta. Sec theta means hypotenuse divided by adjacent side. Adjacent side. Hypotenuse divided by adjacent side is equal to sec theta. It is the reciprocal ratio of cosine or cos theta. Now, the third ratio tan theta and its reciprocal means adjacent side by opposite side. That is cotangent. The full name is cotangent and its short form is cot theta. The third form, cot theta, is equal to adjacent side divided by opposite side. This is the reciprocal ratio of tan theta, which is cot theta, and its full name is cotangent. This is the full name. So, the six ratios are obtained, such as sin theta, cos theta, tan theta, and their reciprocal ratios cosec theta, sec theta, and cot theta. When we are hearing the word sine, we have to remember it is opposite side by hypotenuse, and on hearing cosine or simply cos, it is adjacent side by hypotenuse, and tangent means tan. Tan of the angle is equal to opposite side by adjacent side. Then the three reciprocal ratios are there. The reciprocal ratio of sine is cosec theta, and the reciprocal ratio of cos is sec theta, and the reciprocal ratio of tan is cot theta. Now, we can write the reciprocal of sine. What is the reciprocal of x? The reciprocal of x is 1 by x. Similarly, we can write the reciprocal ratio of sin theta as 1 by sin theta. That is 1 by sin theta. 1 by sin theta is equal to cosec theta. Since cosec theta is the reciprocal ratio of sin theta, we can write 1 by sin theta is equal to cosec theta, and hence, therefore, 1 by cosec theta. 1 by cosec theta is equal to sin theta. For example, if 2 is the reciprocal of 1 by 2, then 1 by 2 will be the reciprocal of 2. What is the reciprocal of 2? It is 1 by 2. Similarly, the reciprocal of 1 by 2 will be 2. Another example, what is the reciprocal of 3 by 4? The reciprocal of 3 by 4 is 4 by 3. Therefore, the reciprocal of 4 by 3 will be 3 by 4. In the same way, if the reciprocal of sin theta can be expressed as 1 by sin theta is equal to cosec theta, then the reciprocal of cosec theta can be expressed as 1 by cosec theta, which is equal to sin theta. 1 by sin theta is equal to cosec theta, and 1 by cosec theta is equal to sin theta. Next, cos theta. The reciprocal of cos theta can be expressed as 1 by cos theta. 1 by cos theta is equal to sec theta. Therefore, the reciprocal of sec theta can be expressed as 1 by sec theta. 1 by sec theta is equal to cos theta. if the reciprocal of cos theta is expressed in the form 1 by cos theta which is equal to sec theta, then the reciprocal of sec theta is equal to cos theta. That means 1 by sec theta is equal to cos theta. Now, the reciprocal of tan theta, we can write it as 1 by tan theta. 1 by tan theta is equal to cot theta. The reciprocal of tan theta means 1 by tan theta is equal to cot theta. Therefore, the reciprocal of cot theta, it is expressed as 1 by cot theta. 1 by cot theta is equal to tan theta. Now, this is very, very important. We are always using these formulas when doing problems. So, be very, very careful by studying this. 1 by sin theta is equal to cosec theta. 1 by cosec theta is equal to sin theta. 1 by cos theta is equal to sec theta. 1 by sec theta is equal to cos theta. And 1 by tan theta is equal to cot theta. 1 by cot theta is equal to tan theta. We have to by heart these relations for doing problems. And we have to study the basic terms also. That means sin theta is equal to opposite side by hypotenuse, cos theta is equal to adjacent side by hypotenuse, tan theta is equal to opposite side by adjacent side. We must study these results also. Okay.